Okay, in this video, we'll start our series on integration techniques. So the first technique would be integration by parts. We'll be answering a few questions that wherein we apply this technique. So essentially the goal for integration by parts is to usually you apply this when you see logarithmic or exponential functions, trigonometric functions, inverse trigonometric functions, possibly also products of algebraic or trig or inverse trig or log or exponential functions. So simply, in our first example, we have an algebraic x squared and we have an exponential e raised to x. So usually integration by parts, that's how we solve this integrand. So we have a u, we have a dv, and don't forget the integral sign. You have to choose which, whether it's x squared or e raised to x, if you write it that way. Ideally, what you're supposed to end up with after finding the after finding the derivative of your u and integrating your dv, you should have simpler forms. What do I mean by that? Let's see. So when I differentiate x squared, so we have 2x dx. In the other side, when we integrate e raised to x, that's essentially just e raised to x. So let's compare. What if our u, we're supposed to write the x over there. What if our u was e raised to x instead, and our dv was x squared dx. So du is equal to e raised to x, right? And then our dv, the integral of dv is v. General power rule, I think that's the case. That's what you call it. Essentially, it becomes like this. So comparing these two, which do you think is simpler? So yeah, this is simple. That's okay. But here it became more complex, right? It's much easier to deal with this compared to this. So in that sense, we don't continue solving using this set. What we had earlier, we'll stick with that. So essentially, for integration by parts, there's this formula. So integral u dv is equal to uv minus integral v du. So substitute. X squared is u, right? And e raised to x is the v. Minus integral of v, which is e raised to x, times du. Du is 2x dx. So e raised to x squared minus 2 integral e raised to x e raised to x dx. The order doesn't matter. Again, for example, 2 times 3 is 3 times 2. So whatever order you write your expression, it doesn't really matter. We're still in the right tracks. So what do we do now? We again have an algebraic x and then an exponential e raised to x. So we do the same thing. We still apply integration by parts. So for the time being, u and then dv, let's try u as e raised to x. Actually, no. Let's try u as equal to x. Du is therefore equal to dx. For dv, e raised to x. V is equal to e raised to x. Supposedly there's a plus c, but we don't do that in this part of integration because that's not the final answer. So now let's put them here. So u times v minus v du. Okay. At this point, now this is integrable by basic, if you get what I mean. Essentially, it's this, right? So that becomes e raised to x. Now let's simplify. Distribute -2. Let's just check if my answer is correct. This is integration by parts, right? Okay. Modules. Okay. So there's a common factor here. Thus you're not forced to, but you can express your answer like this. Don't forget the plus c, by the way. We are still solving, what do you call this? Indefinite integrals. So there are no fixed numbers yet, so we have to put a plus c because we don't know what this constant is. So yeah, this is the correct answer. Either way, this is also correct. Okay, that's settled for number 1. Number 2. Okay. Integral x squared arctangent of x dx. Okay, so this time we have an algebraic x squared and an inverse trigonometric. Well, you're already seeing it. Let's assign. Perhaps, let's try this, and then here. What is the integral of inverse tangent? Sorry, arctangent x. So there's this formula. It goes like u squared plus a squared du over u. This is equal to 1 over a. Maybe this is a different thing. Yeah, this is different. Perhaps. Give me some time to think. Yeah, okay. So at this point, I think it is better if we assign the other way around. Let me just make sure that that's actually the only way. What is the, don't forget the integral sign, integral of arctangent? That's actually possible. However, you'll end up in a more complicated you will end up in a more complicated position. Let's actually try it, just for the sake of practice. So, again, we still have to, whenever you see something like this, that itself is an inverse trig function, and if you want to integrate, you choose integration by parts method Or at least that's one of the choices for solving. Okay? So u is equal to let u equal to arctangent of x. Du is equal to, so its derivative is equal to 1 over, no, dx over x squared plus 1. Or like 1 plus x squared. Doesn't really matter. Here it's just dx, right? So v is equal to x. Now, the formula u times v minus integral v du. So let's see. U is equal to 1 plus x squared. Du is equal to 2x dx. I think it is possible. Let's rewrite it like this. 1 plus x squared raised to negative 1. N is equal to negative 1. I think we can use exception to the general power rule. It goes like this. Du. Okay, so since we have a 2 here, this is seen in the integrand, so we can actually use exception to the general power rule. So 1/2 outside 2x du over u. And then that basically becomes ln u plus c. Okay? How about the other side? At that point, we just copy. Okay, so this is, I believe, what's being, so as you can see, if we try to integrate this one, v is equal to this. So it's a much more complicated position. So let's try the other way around. What if u, we decided that it would be arctangent x? And then for integral dv, we chose x squared dx. So v is x cubed over 3. How about this one? How do we differentiate that? So essentially in differentiation, if it's arctangent x, we have dx over 1 plus, because it's a squared plus u squared, such that a is the constant being 1. U being x. So yeah, that's it. So this is much more simpler compared to this, right? U v minus integral v du. Substitute. V is x squared times 1 over 3 minus integral v du. Okay. Now what? How do we integrate this fraction? We cannot apply partial fraction decomposition. That's another technique of integration, for the reason that uh, essentially if the highest degree of your numerator is still higher compared to that of your denominator, or if they're equal. So yeah, if they're higher, you don't apply PFD, or partial fraction decomposition. Only if it's the opposite. Namely, for example, if you have x instead, this one is valid because the highest degree of your numerator is 1. So it's lower than that of your denominator. But that's a topic for a different video. So like, right now, we can apply long division or synthetic division. But let's try first if, by the way, I didn't think of this. Anything that I read, I write it in red because that's not, I didn't think of that naturally. So it helps me practice. Anything that's black, I thought of that myself. So just to let you know. 2x dx. I don't think this is... I don't think this is gonna work. You know what? Let's actually just check it. Assignment 1.7. Wow. The solution is long. So this will not work. Namely because x is not x cubed. It has to be at least be the same degree. So yeah. We can solve by division. Let's There is a method. However, that's its nature is algebraic. Yeah, long division is supposed to work. Okay, so always remember the denominator is always here, and what's inside is the numerator. So alright, so x raised to 1 there. I think that's it. Synthetic division of polynomials. Okay, so multiply, right? X cube, and then no. let's try to redo this. Yeah, if x raised to 2 doesn't work, then just stick with x raised to 1. So when we multiply x squared and x raised to 1, that makes x cubed. And multiplying 1 and x makes basically gives us x. So what we have, therefore, is, so this becomes 0. We have a negative x. And I think that's basically going to be it. Because, well, if you say multiply by 1, that wouldn't make sense, right? So this is where we stop dividing. So at this point, how do you how do you write the answer after dividing? So essentially, what is located here is written there. This one is your denominator, this one here, and this one goes here. Don't forget the plus, the minus sign. Originally this is plus, but because there's a negative sign, just write it like this. So that is how you divide. At this point, you can, since these are two separate, say, entities, what you want to do is, oh yeah, separate them. So 1 over 3 integral x over x plus 1 dx Let's try another long division. Okay, that wouldn't work. Okay, so if we cannot do long division anymore, another trick we could use is, so let's say u is x squared plus 1, right? And du, the derivative of it is 2x dx. So as you can see, x is seen in the integrand. Therefore, we can apply, since also n is equal to -1 because it's here at the bottom, or in other words, in the denominator position, we can apply exception to the general power rule. So integral du over u is equal to ln u plus c. So let's do exactly that. 1 over 3, don't forget the 2 here. That makes 1 over 2 from outside. And let's integrate already. Ln u, which is x squared plus 1, plus c. Okay. And at the other side, the integral of x is simply 1. Sorry, no. Yeah, this is actually, so since this is raised to 1, right? I think you apply what's called the general power rule. So x1 plus 1 over 1 plus 1. So that makes x squared over 2. You remove the integral sign, and that is your simplified answer. Okay, now we've already gotten rid of all of the integral signs. That means we have finished integrating everything that we have to integrate. So at this point, we just have to simplify our answer. Damn, that took time. One over 3 x cubed arctangent x minus 1 over 6 x squared plus 1 over 6 ln x squared plus 1 plus c. Let's see if the answer is correct. All right. So yeah, that's a green signal. We got it right. Another render of the answer would be factoring 1/3 from each term. Although I don't think that's going to be necessary anymore. We got the answer anyways. So that's winning enough. Let's move to the next question. Number 3. So for number 3, integral x secant squared x dx. Okay, so we have u, integral dv, we have a du, and we have a v. So for u, if we put secant squared x as our dv, what is the integral of secant squared x? I think it's tangent x, because the derivative of tangent x is secant squared x, so antiderivative. The concept of antiderivative. X here, on the contrary, becomes this. I think it's a good, I think we're good to go. Hold on. What if u is secant squared x? Okay, that's gonna be more problematic because, oops. Are we good? Okay. So, as I was saying, if u becomes x, if u becomes secant squared x, ideally it's only secant x, so that the derivative is secant x tangent x. But that's not the case, so we're just gonna make it more complicated if we chose that path. So we have uv minus integral v du. U is x, v is tangent x, minus integral of tangent x du, which is dx. Okay, x tan x, just copy, minus, what is the integral of tangent x? This is simple. So there's this formula that you have to memorize. So whenever you see integral of tangent x, it's negative ln cosine x plus c. Okay, let me just confirm if I got that right. Ideally, I will have memorized it by now. All right. Yeah, I got it right. Okay. We'll leave that aside. Okay, so now that we have our replacement, so this becomes positive, no? Okay. So that's basically it for this number. Is it? Let's see. All right. Yep, this is the answer. Next question. Integral of arcsine x dx. So, okay. So it's a good thing that earlier we did attempt to integrate the arctangent of x. So in this case, we have an idea that we actually have to apply integration by parts whenever we see an inverse trigonometric function expressed in this way. So I think this is the most common way of expressing an inverse trig. So yeah, in that case, dv dx, and the inverse trig is always going to be u. I think that's the only way to solve it. So let's apply that same logic. So the inverse trig as u, and for our dv, that is going to be, well, just dx. So after integrating, v is equal to x. So differentiate arcsine of x. That's going to be dx over square root of a squared minus u squared. A being 1, so 1 raised to 2 is still 1. U squared, u being x, so x squared. I think that's it. Then we write it like this. Substitute. U is arcsine of x. V is x. Du dx over square root of 1 minus x squared. Okay, what do we do next? How do we crack this? I think since this is x squared, the degree is not greater than 2. Let's try differentiate negative 2x dx such that n is negative 1/2. Yeah, it works. Yeah, originally this wasn't my idea. I'll put it in red. I need to practice this part. By default, you're supposed to know that this is what you do. You don't stare at your paper with a blank face. No, no. Wait. So integral u du plus 1, right? General power rule. We cannot use exception because this is not, n is not equal to negative 1. That's a condition that you have to follow. In this case, it wasn't followed. 1 minus x squared raised to 1/2. Below, 2 over 2, 1 over 2, 1, 2. Okay. Remove the integral sign already because we are already done integrating. So square root of 1 minus x squared plus c. Don't forget the plus c. So, alright. Yeah, this is the final answer already. Nice. Okay, I think we're getting up to speed. We're at the 5th question already. Pi over 2 and then 0. Okay, this time we're dealing with a definite integral. So, first you have to integrate, of course. Then later we apply something that goes by f of b minus f of a. So again, remember, in definite integration, you don't put a plus c anymore because we have an upper and lower limit value. So since we have an algebraic x and a trigonometric cosine x, we can apply integration by parts. So u is equal to, let's try cosine x, du being negative sine x. Integral dv is equal to x dx, v being equal to x squared over 2. u equal to x, du equal to dx, dv equal to cosine x dx, v equal to sine x. Okay. So we'll ditch this. We'll go with this. This is simpler. So mind block? Nope. Just need to pause from time to time. X sine x minus integral sine x dx. The integral of sine x is negative cosine x. Don't forget that we are now dealing with a definite integral, so we have a lower and upper limit. We don't put a plus c. So yeah, pi over 2 and then 0 x sine x plus cosine x. Okay. Now we apply this here. So pi over 2 sine pi over 2 plus cosine pi over 2 minus 0 sine 0 plus cosine 0 pi over 2. Okay, in the unit circle, sine pi over 2, right? Pi over 2 is 90 degrees. At this point, we have 0, 1, cosine, sine. I think sine pi over 2 is 1. Let me just confirm that with the calculator. Where is my calculator? Bruh. Sine pi over 2. Okay, it is not equal to 1. The heck? In the meantime, on the other side, okay, cosine 0 is 1, I think. Is that correct? Yep. But sine 0 is always going to be 0. Wait, I really think sine pi over 2 is equal to 1. I think it's because my calculator is in radians. How do I? Angle unit radian. Let me try that again. Sine pi over 2. There you go. I knew it. The logic in the unit circle is supposed to be correct. Because, again, pi over 2 is 90 degrees, right? So, this is quadrant 1. And when you reach 90 degrees, the coordinate is 0, 1. In the x position, that's your cosine. In the y position, that's your sine. So, let's say we have cosine pi over 2. So, your cosine here is 0. So, cosine pi over 2 is 0. Sine pi over 2 is equal to 1. So, that's the logic. If you're asked for tangent pi over 2, good luck. I wouldn't know what to put if that was the case. Sine pi over 2, again, it is equal to 1. Okay, so yeah, we just answered this. Nice. So that's 0. So pi over 2 minus 1. That's the final answer. Okay? Not so bad. I've seen worse. In algebraic manipulation, trig substitution, and transformation, each problem is 1 page long on this application. So just to give you an idea, this is how big the paper is on my iPad. Okay, number 6. What? Okay. Okay, so right now we have trigonometric materials. I'll just call them materials. Wife material, math material, trig material. Let's try sine 3x du is equal to 3 cosine 3x dx. Integral dv is equal to cosine x dx. V is equal to sine x. Okay. Let's try what if u was cosine x. Du is equal to sine x dx. Don't forget the negative sign. Integral dv is equal to sine 3x dx. V is equal to cosine negative. Oh, I think I'll stick with what we have. There's no negative. Okay, u v minus integral v du. I decided to place a constant before the integral in advance because eventually that's what you're supposed to do. Okay, at this point, we have to apply integration by parts one more time because we landed in a really similar scenario. So we still have two terms that are trigonometric functions. Okay, I think everything's okay. U v minus integral v du. Okay, so we just landed in the same if you notice, basically this is exactly the same as this. So what do you do in this scenario? Simplify first what we just got, but do this in advance. Write down the given integrand because eventually we'll move this to the left side together with it. So just simplify for now. Minus 3 sine x sine 3x plus 3 integral sine 3x cosine x dx. Positive 3. Okay. So we'll have, if you move this to the left side, negative 3 plus 1 is negative 2. Integral sine 3x cosine x dx equal to sine 3x sine x minus 3 sine x sine 3x. And then divide both sides by -2. Since we're still dealing with a definite integral, don't forget pi over 3 and 0. Wait, I think something's wrong. Oh no. Nothing major. Actually, it is major. I'm gaslighting myself. So when you integrate this, don't forget, we have a 1 over 3. Actually, you just don't think that because this is cosine, we get sine. It's not that easy. U is equal to 3x. Du is equal to 3 dx. This is where you find out that we actually have a 1 over 3. So uv minus, oh wait, no. Did we have to? No. There's nothing wrong here. Rather just over here. Okay, so when we distribute the 3, the fractions would be removed. Okay, so we don't actually have a -2. Something's not right. This is actually crazy. Let's try this method. Because ideally, either way should be fine. U, wait. Integral of again, u is 3x, du is equal to 3 dx. So 1 over 3, the integral of sine is cosine. Negative cosine actually. So, okay. uv minus integral v du. Apply integration by parts one more time. U is 3x, du is 3 dx. 1 over 3 sine 3x. U v minus integral v du. Surely let's just distribute the sign already. Okay. Now we equate. Two over three integral Holy airball. I actually forgot something. The 1/3 here. Simplify first. Wait, why is this positive? This is supposed to be minus. UV minus integral V du. I don't see any negative here, so there's no justification for it being positive. So when you distribute, that becomes a positive. Okay, so when we move it to the other side, technically here we have a 9/9, since 1 is also equal to 9/9, which is invisible. So 9/9 minus 1/9, that's 8/9. And so divide both sides, both equations by 8/9. Technically, this could be rewritten as 9/8 times 9/8. Yeah, I think that's it. At this point, if our given was not a definite integral, this could have been the answer with a plus c. But again, we have an upper and lower limit, so we need to substitute. Cosine, oh no, this is pi/3. That's actually doable. Pi/6, pi/4, pi/3. In pi/3, we have 1/2 square root 3/2. Cosine pi/3 is 1/2. Pi is at the other side, at this part. That's 180 degrees. At this point, we have a -1 and a 0. Cosine pi is -1. Let me confirm. Yep, it is a -1. Minus 1/8 sine. So sine pi/3, it's square root of 3/2. Sine pi, sine, is 0. Okay, so 3 over 16 plus 3 over 8. 9 over 16 is the answer. Yep, we got it right. That's crazy. I still wonder why this solution did not work. Okay, so this is obviously wrong already. But like, either way, it's supposed to work. Maybe I haven't spotted the problem yet. Okay. U is equal to okay, I think this would work. We'll see. It's not a nice position. I think this is a pick your struggle situation. Both of them are complicated. I'll take a guess at what at which I chose in the answer key. Damn. Okay. Never mind. Let's skip this. You know what? Let s equal to x. I'm always used to x. Let's keep it that way. Wait. Oh, so this is still positive. Let me confirm that. Yeah, it's actually positive. Wow, that is smart. Because negatives will cancel. Originally, when it's integral of sine, that's actually negative cosine. But because of this, we have another negative, so that makes it a positive. Genius. It's crazy if you don't go through this process. You're not supposed to skip that. So right now, clearly this is simpler compared to this. The only difference is the negative sign. Actually, wait. Oh, yeah. Okay. U v minus integral of v du. Okay. Ah, okay. So we put the integrand here. We can rewrite this like this. And now it's easier to assimilate. This is the same as this. Don't forget to write the dx. So when we transpose to the left, we will have a 2. And then just copy. And then divide both sides by 2. We will have oh, yeah, Don't forget the plus c. This is, we don't have a lower and upper limit. Yeah, we got the answer right. The answer was in the form such that we factored 1/2 and e raised to x. So we have there you go. All right. Smooth sailing for number 8. Let's go with number 9. Okay, in this situation, I think we have to equate dv as to dx. I think this is the only way. We don't really have much of a choice. We'll see. U is equal to ln x, right? So du is equal to 1 over x dx. Cosine ln x times okay, so u v minus integral v du. I think we can cancel the x. Another integration by parts. Same approach. From cosine to negative sine. Ln x and then its derivative, which is 1 over x dx. Okay, so x sine ln x minus u v minus integral v du. Okay, similarity. We equate again our given. They're exactly the same, so we can combine, right? Like terms, like to like. So divide both sides by 2. I think we can factor x from these two terms. So 1 over 2x sine ln x minus cosine ln x plus c. Is this definite? No. So we can put a plus c. This is the final answer. Let's see if it's right. What number is this again? Number 9. Okay, correct. Let's proceed to number 10. Okay, so this is a tough choice. Wait a minute. What if it was the other way around? Okay, this is much worse. I wouldn't know what to do after that. U V minus V du. Okay, we can cancel something. Feels like it was actually meant to cancel. U is x, du is equal to dx. Okay, nothing changes. Sine x. Don't forget the plus c. We can factor, although I don't think this is mandatory, but you can do it anyways. Let's see if it's correct. Number 10. Alright, correct. Number 11. I wasn't supposed to do that here. This is integration, not differentiation. Rather, like this. Okay, which is simpler? I don't know. Which is simpler? Uh, I'll stick with this. Let's try it out. So UV, U, V. Oh wait, sorry. This is supposed to be du. U, V, minus integral V du. Is this simpler? I think we just... I don't know. Let's try the other one. U, V, minus integral V du. 1 over 5 x raised to 5 ln x raised to 2 minus 1 over 5 I think this is a simpler solution. So integration by parts again. What was our u previously? Ln x, right? So we'll do the same. Ln x. X raised to 4. V is equal to x raised to 5 over 5. Okay, same thing. 1 over 5 x raised to 5 ln x squared minus u v minus integral v du. Okay, so we can now further simplify by basic integration, specifically this part. Everything else we simplify. So 1 over 5 x raised to 5 ln x minus 1 over 5 x raised to 5 over 5, just 1 over 25 x raised to 5 plus c. Did I miss something? Oh wait, I forgot to write this. Yeah, so 2 over 25 and then distribute there. We'll have 2 this is supposed to be 25. Hold up. Okay, so after distributing, so far so good. Yeah, this part is good. How about this part? So 2 over 5 times 1 over 5, that's 2 over 25. Then just copy. Then we integrate. 2 over 25, x raised to 5 over 5. There you go. And then just copy the rest. This eventually becomes 125. So yeah, that is the answer. Last question. I'm running out of time. I still have 4 or 5 other techniques to discuss. U v minus integral v du. I think in the denominator we can simplify it as that, and then okay, wait. We can apply long division. X cubed plus x minus x minus x over x squared plus 1. Okay. This is very similar to what we did earlier, so yeah, it's not taking that much time anymore. Exception to the general power rule can be done, so ln u plus c. This one, that's just x raised to 2 over 2. Okay, let's check if the answer is correct. Hmm. Wait, so let me recalculate. Some we got the right answer for the most part. It's just not. I want to clarify if the answer key is wrong, and our solution right now is correct. Hmm. Wait a minute. Integral x dx. It's really insisting that the answer is just this. But how about for this part? Hmm. That's very strange. Anyways, I'll end the video here. It's too long already. Um, I'll leave that to you. Figure out why this part isn't included. Okay, thanks for watching.